All right. Hello, everyone. Assalamu alaikum. Let's begin. So we are starting with our next topic today, which is sequences. Uh, we will hopefully cover all the concepts that we need to do in this topic today, and do some practice questions as well. So let's begin with this and just set a couple of things up, and then we begin. So I have this working. All right, let's begin with this then. Sequences and patterns. This is what we are doing today. So there are a number of different types of sequences that you will come across in O-levels or IGCSE. You would have quadratic sequences, you would have linear sequences, quadratic sequences. You have cubic sequences in your syllabus as well, although they're not tested as much, but they can also come. Sometimes you have exponential sequences where you have some number multiplying to get the next term. And then you have some patterns that you have to figure out from question to question. You have to figure out looking at the question statement yourself, and the any tables that you might be given some tables using which you might have to figure out some patterns there. So that's what we will be covering today. Let's start first of all with the most basic of the sequences, and that's called an arithmetic sequence or a linear sequence. Okay, so that's the first type of sequence that you will come across. We call this an arithmetic sequence, and we sometimes also call this a linear sequence. Okay, so they're both names for the same thing, arithmetic or linear. Now, let's take an example. Let's say we've got something like this: 2, 8, 14, 20, 26, and so on. We have a number sequence that looks like this. Now, can we guess the next term from from looking at these numbers? We can see the differences between these numbers, they're all constant, right? So we have 6 here, 6 here, 6 here, 6 here. So in order to get the next term, all we are doing is we're just adding 6 to the previous term, right? So if you had to write down the next few terms of the sequence, that will be pretty straightforward. You will just add 6 more to 26, and that will give you the next term. So that will be 32. And the next one, that's going to be 38. And then the next one, that is going to be 44, and so on. You can write down the next few terms like this. Just keep adding the same numbers again and again. Okay, so this is one type of sequence where the difference between consecutive terms is constant. That's not changing. So in this case, that difference is 6. That was constant. That's not changing. This is called a linear sequence. Let's take a couple of more examples. Let's say you have something like this: 3, 7, 11, 15, 19, 23, and so on. You can see the difference between these numbers is 4. And that's a constant difference. That's not changing, right? This is also a linear sequence, an arithmetic sequence. If we were to write down the next few terms, we could say the next term is going to be 27 after this, and then plus 4, 31, plus 4, that's 35, and so on. Okay. Now the numbers could be increasing or they could be decreasing. Both possibilities are there. So you could have something like this as well. For instance, you might start with 11, and then you might have 8, 5, 2, -1, -4, -7, something like this. You see what's happening? The difference between the consecutive terms, that is -3, because the terms are decreasing. So the next terms could be -7, -3, that's -10, and then -13, -16, and so on. This is how we could write down the next few terms of the sequence. Okay. Now, that's one thing that you have to do, that you'll have to write down the next few terms of the sequence. Then you should be able to write down the nth term of any sequence, right? So for all of these sequences, you should be able to write down their nth term. Now, what's an nth term? Let's try to understand that using a linear sequence as well. So let me write down the formula first of all, then we'll try to understand that. The nth term of a linear sequence or an arithmetic sequence is given by this: a plus n minus 1 times d. This is the nth term formula for an arithmetic sequence: a plus n minus 1 times d. You need to make sure that you remember this. Tn here stands for the nth term. It's the value of the nth term. N means the position of a particular value in the sequence. What does that mean? So in this case, for instance, 2 is the first value, so that's 1. 8 is the second value, that's that's number, n is equal to 2 in this case. 14 is the third value, n is equal to 3 in this case. And then 20 is the fourth value, n is equal to 4 in this case, and so on. So n basically tells you the position of that particular value. So in this case, when n is 1, the value of the sequence is 2. When n is 2, the value of the sequence is 8. When n is 3, it's 14. So n represents the position at which you have a particular value. Okay. What about a? A stands for the first term of the sequence. A is the first term of the sequence. First term of the sequence. And D is the common difference between the terms. It's the common difference between the terms. Using this formula, what we can do is we can find the nth term of an arithmetic sequence of a linear sequence. Now, what's an nth term? Let me write it down for the first sequence here. We'll try to figure it out using the formula later on, but let me just tell you for now. This nth term for the first sequence would look something like this. It will be 6n minus 4. So for the first sequence, the nth term formula is going to be this. It's going to be 6n minus 4. Now, why is this the nth term formula? Because when I input n equal to 1 in this, what value do I get? 6 times 1 minus 4, that's 2. When I input n equal to 2 in this, what value do I get? 6 times 2 minus 4, that is 8. When I input n equals 3 in this, I get 6 times 3, which is 18, minus 4, that's 14. And so on. N is equal to 4 is going to give us 20. So this is a formula that we can use to find every single term in the sequence: 2, 8, 14, 20, and so on. Right? So this formula can give us every single term in the sequence. This formula is known as the nth term of a particular sequence. Okay? 6n minus 4 is the nth term of the sequence. Now, how do we find that? For now, I just wrote it down. This is the formula that you can use to write down the nth term of any sequence. Okay, now how do you do that? There are two things that you would need to be able to write down this nth term. Number one, you would need the first term of the sequence, which is a. Okay. Number two, you would need the common difference. If you have these two things of a linear sequence, you can write down the first term of the sequence and the difference between the terms for a sequence. So let's try to do it for the second sequence here. What's the first term? The first term in the second sequence is is 3, right? So we can say this is the value of a that we've got. What about the difference? How do we find difference of a sequence? We take two consecutive terms and we find the difference between those terms, keeping in mind that we should be subtracting the previous term from the next term. So if you take any two terms, for instance, if I take these two consecutive terms, this is the next term, this is the previous term. So I'll be doing 15 minus 11, which in this case turns out to be 4. Okay. So for this second sequence, the difference is equal to 4. And what about the value for A? The value for A is equal to 3. Right? So I have D equal to 4, A equal to 3. What I can do now is I can use the nth term formula that I wrote below there to find the nth term of the sequence, because the formula looks like this: A plus n minus 1 times D. I know the value of A is 3. I can just input that here. And the difference was 4. If I input that here, that gives me 3 plus 4n minus 4, which simplifies to 4n minus 1. That's the nth term sequence. That's the nth term formula for this second sequence, 4n minus 1. Okay. If you input n equals 1 in this, that gives you the first value here. If you input n equal to 2 in this, that gives you the second value, and so on. You can find the rest of the values in this sequence. We could do the same thing with the next sequence as well, but now we have to be careful. What is the difference going to be? Difference is given by the next term minus the previous term in a sequence like this. So if we find the difference for this sequence, if we take any two consecutive terms, if I take these two terms, for instance, the difference is going to be given by 8 minus 11, which is negative 3. Okay, don't just subtract the smaller number from the bigger number. You have to subtract the first number from the second number. So next term minus the previous term. In this case, that gives me 8 minus 11, that is negative 3. So the value of D is negative 3. What about A? A is the first term of the sequence. The first term of the sequence is 11. That's 11. Now using this formula that I wrote there, I can write down the nth term of the sequence. Tn equals A plus n minus 1 times D. Let's input values in this. A is equal to 11 plus n minus 1 times the difference, which is negative 3. We could simplify this, and that gives us 11 minus 3n plus 3. And that simplifies to minus 3n plus 14, or you could say 14 minus 3n. That is the nth term formula for the second sequence. So for a linear sequence, this is how you can write down the nth term formula. The nth term formula is given by A plus n minus 1 times the difference. Okay, A plus n minus 1 times the difference. You need to memorize this. It will not be given. For a linear sequence, that's the formula. Now, if I were to write down a sequence here, let's say I have something like this: minus 5, 2, 9, 16, 23, and so on. This is a sequence that I have. Now, is it a linear sequence? Is it an arithmetic sequence? Let's think about it. Yes, because the difference between the terms is constant. This is 7. This is 7. This is also 7. All of these differences are the same. Now, given this sequence, if I were to ask you, find the 40th term of the sequence. Find the 40th term of the sequence. Now, how can we do that? 40th term of the sequence. One possibility is that we keep writing down these values, keep writing down the next terms, but that will be too long. That will take too long, right? What we can do is we can write down the nth term of the sequence and then use that to write down that 40th term. Now, how do we write down the nth term formula for this? What's the standard formula that we've got? Let's write that down first. A plus n minus 1 times D. What's the value of A that we've got? in this sequence is the first term, that's -5. Okay. What about the difference? Next term minus the previous term. Take any two consecutive terms. If I were to take these two terms, that will give me 9 minus 2, and that is 7. Okay, so difference is 7 is -5. Just input that in these value in this formula and see what that gives you. The nth term formula for the sequence turns out to be -5 plus n minus 1 times the difference, which is 7, and that simplifies to -5 plus 7 and minus 7, which is 7n minus 12. That's the nth term formula for this particular sequence. Okay, you can verify this as well. N equals 1 gives us -5, n equals 2 gives us 2, n equals 3 gives us 9, and so on. So this formula is correct. Now, what are we looking for? We're looking for the 40th term of the sequence. 40th term means we're looking for T40, right? This is T1, this is T2, this is T3, this is T4, and so on. We want T40. We want the 40th term. All we have to do is input 40 in place of n here. And that will give you the term value when it's the 40th term. Okay. Now, just input that here. 7 times 40 minus 12. And that should give you the answer. 40 times 7 is 280. 280 minus 12, that should give you 268. That's the result that we were looking for here. Okay. So this is how we can use this formula. All right. Now, let's change this slightly. Let's add another part to this. Let's say we have to do something like this. They might say, given that the kth term of the sequence is, let me figure that out. We have 7 there. Okay. $219. Okay, that's the kth term of the sequence. 219. Find the value of k. Find the value of k. That's what you want. That's what you want to do now. The kth term of the sequence is 219. You are given the value of the kth term. You want to find what k is. Okay. Now, do we already have the nth term formula for the sequence? Yes, the nth term formula looks like this. It is 7n minus 12. Okay, and this is a sequence for which we know the first term is -5, the second term is 2, the third term is 9. And what they're saying is the kth term, that means tk, so instead of n, we have k there. The kth term is 219. What's the value of k if that is the case? So what we can say is, if the nth term is 7 and minus 12, what about the kth term? What should that be? That should be equal to 7k minus 12, right? That's the value of the kth term, 7k minus 12. 7k minus 12. Now, do we know what the kth term is? We know the value, that's 219. What we can do is we can just put that here in this equation, and we get 219 equal to 7k minus 12, and that gives us 231 equal to 7k. We can find the value of k from this. You can see what that is. 231 divided by 7, that's 33. So the value of k should be 33. Okay, so when k is equal to 33, that is when the value of that term would be 219. That's what we were looking for. Okay, so that's one type of sequence that you need to be familiar with, an arithmetic sequence. Okay. All right. So I hope that makes sense. You should be able to write down the nth term of the sequence. You should be able to write down the next few terms of the sequence, and you should be able to figure out which term number it is given the value of that term. Okay, so this is the most commonly tested sequence, and it's the easiest one as well. But then we have some other types of sequences too that you need to be familiar with. Number one of those is quadratic sequence. Quadratic sequence. Now, what do quadratic sequences look like? Let me write down a sequence here that looks like this. Let's say I have 3, 6, or start from another number. Let's say I have 7, and then I have 9, 14, 22, 33, and 47, and so on. Let's say I have a sequence that looks like this. Yeah, so this is a sequence that I have. Now, is this a linear sequence? It's not, because you can clearly see that the difference is not constant, right? The difference is not constant. The first difference is 2, then the next difference is 5, then the next difference is 8, then the next is 11, and then the next is 14. So the differences are clearly not the same. Okay? The differences are not the same. That means it's not a linear sequence. All right? Okay, so if it's not a linear sequence, then another possibility is that it's a quadratic sequence. Okay? How do you know if something is a quadratic sequence? You find the second difference. Okay, so this thing that I've calculated in green, we call this the first difference. The first time you calculate a difference of a sequence, it's called the first difference. We can represent this by D1, let's say, or you can just say D as well, or D1. But then if I were to find the difference of these differences, so difference between 2 and 5, what's that? That's 3. Difference between 5 and 8, that's also 3. Between 8 and 11, that's also 3. Between 11 and 14, that's also 3. This is called the second difference, the difference of the difference. Okay, we call this the second difference. Let's write that down here. That's the second difference. If the second difference is constant, then that means it's a quadratic sequence. Okay, in this case, this is constant. When the second difference of a sequence is constant, this is a quadratic sequence. All right. Now, if you were to write down the next few terms of this sequence, how can you do that? Notice the pattern. You're adding 2, and then you're adding 5, then you're adding 8, and then 11, and then 14. Every time you're adding 3 more than what you were adding before. So we were adding 2 first, and then we said, let's add 5. That's 3 more than 2. Then next time we said, add 8. That's 3 more than 5, right? So every time we're adding 3 more than what we were adding before. So the next term in this case should be 47 plus 17, and that should be 64, and so on. The next time we should be adding 20, and that will be 84, and so on. Okay, so the next few terms can be written like that. But what if you had to find the nth term of the sequence? How do you find the nth term formula for this quadratic sequence? Remember this formula for the linear sequence? It was a plus n minus 1 times the difference. We can write a similar formula for a quadratic sequence as well that starts from the same thing. It starts like this. Tn equals a plus n minus 1 times d. Okay, that's the formula for a linear sequence. For a quadratic sequence as well, it starts like this. But then this is d1, right? The difference that we've got here. This is d1, the first difference. For a quadratic sequence, we add another term to the sequence. And that other term looks like this. We say it's d2 times n minus 1 times n minus 2 divided by 2. We add another term here that looks like this. Or if I were to write it slightly differently, you can think of it like this as well. N minus 1. It's the same as before, but instead of just n minus 1, we also have n minus 2 here, divided by 2 times d2. Okay, so for a quadratic function, for a quadratic sequence, you can use this formula to write down the nth term of that sequence. Now we can figure this out for this particular sequence. Now, we know the first difference, that is changing, right? In this case, the first difference is changing. But the second difference, that is constant. That's just 3. Okay. For the first difference, we will just use this first value here. Okay. So since it's changing, it's like 2, 5, 8, 11, 14. It's constantly changing. We basically we use the first difference as just t2 minus t1. So the first difference is going to be just this first value, the first difference between the first two values. That's what we use here. Okay. For the second difference, since it's constant, we can take any of these values. We can just say that's 3. We can write down this nth term formula for the quadratic sequence like this now. The first term is 7. Let me write that down here first of all. What's the value of a that we're using? The first term is 7. d1, that's this first difference that we have. The first difference from the first two terms of the sequence, that's 2. And then the second difference, d2, what's that? d2 is equal to 3 in this case. We just have to input these values in this formula and we'll get the nth term for this sequence. Let's see what that turns out to be. 7 plus n minus 1 times d1, which is 2 in this case, plus n minus 1 times n minus 2 divided by 2 times d2, which is 3. And that should give you the result. You can simplify this a bit now. It becomes 7 plus 2n minus 2, n minus 1 times n minus 2. That is going to give you n squared minus n minus 2n, which is minus 3n plus 2 times 3 divided by 2. Let's simplify that further. That becomes 7 plus 2n minus 2 plus 3n squared minus 9n plus 6 whole divided by 2. And that gives us 5 plus 2n, 5 plus 2n plus 3 over 2n squared minus 9 over 2n plus 3. If we break it down, 3n squared over 2, that is 3 over 2n squared, minus 9 over 2 times n, plus 6 over 2, that gives us 3. And then we could finally write this as 3 over 2n squared minus 9 divided by 2 plus 2n. That's minus 5 over 2 times n. And then the constant, that is 8. That's the nth term formula for this quadratic sequence. Now, I actually wrote the sequence randomly from my head. That's why this sequence, the nth term formula that we're getting, it's in fractions. Generally, an exam question that's going to have integer coefficients, and that will be much simpler than this. But that's the formula that you can use to write down the quadratic sequence directly. You can verify this now. If you input n equal to 1 here, you can see what that gives you. N equal 1 gives you 7. Then you try n equals 2, and that should give you 9, and so on. You can check this formula. That's how it would work. Okay. This is the formula for the linear sequence. For a quadratic sequence, then, you just add this one more term. So earlier, you had n minus 1 times d. Now you have n minus 1 into n minus 2 divided by 2 times d2. where D2 is the second difference of the sequence. And how do you figure out if it's a quadratic sequence or not? The second difference must be constant. If the second difference is constant, that means it's a quadratic sequence. Okay. Now, sometimes you'll have to use this sequence. It's going to be rare because mostly you're able to figure out directly from the pattern that's there in the question what the sequence is going to be. But sometimes if there's no other way, this is the backup that you would have. You can use this formula, just plug in values in this D1, D2, and A, and you can get that formula directly from this. All right. Okay. Now let's move on. Another possibility that has not been tested in past papers until now, but it's part of your syllabus. It says that in the syllabus that you have, it's a cubic sequence. Now, why are we calling this a quadratic sequence? The nth term formula that we got, it had n squared in it. For a cubic sequence, the formula would have n cube. So right, n cube plus n squared plus n, and then some constant. You might have some coefficients of n cube, n, and n here. That will be a cubic function, cubic sequence. You can write it like this as well: an cube plus bn squared plus cn plus d. The nth term formula for the sequence is going to look like this. Okay. At the end, if you simplify everything, this is what you should get at the end. Okay. Now, I'm just going to write down the formula. You can try it yourself and see what that gives you, because it is a bit time taking and you'll not find many questions on this. In fact, no question on this in the past papers as of yet. But since it's part of the syllabus, I'm just going to tell you the formula for this and explain to you how this works. So in case, by any chance, you end up having to do it in the exam, you know how to do it. Okay. Now, that's just an extension of the same formula that we used before. What was the formula for the quadratic sequence? It's this that I've shown you on your screen right now. Now, first of all, let me write down a sequence that's a cubic sequence. So this is one example of cubic sequence: 2, 15, 52, 127, 256. This is an example of a cubic sequence. Now, why is it a cubic sequence? How do you figure out? How can you figure this out? If you find the difference between the terms, this is 13. This is 52 minus 15, that's 37. Then this would be 127 minus 52, that is 75. And then the next one is 256 minus 128, which should be 129. Okay, now you find the second difference between these terms. Let's see what that is. 13 minus 13, 37 minus 13, that will be 23. 75 minus 37, that should be 38. And then 129 minus 75, that should be 54. Now you find the difference between these terms. Or maybe I've done something wrong here. Okay, just confirm that. 256 minus 129, 127. That's 129. That's for 75. Okay, that should be 24. I'm sorry. The first difference here should have been 74. Okay, 24, 38, and 54. That's the second difference. Now, let's find the next difference after that. 37, 75. This is fine. 38, 75 to 129. Okay, let's find the third difference. 24 to 38. What's that? That is 14. And this is 16. Okay, can you figure out what the issue might be on the 7256? Because the third difference is not turning out to be constant. 13, then 37, that is fine. 127 minus 75. Can anyone spot a careless error anywhere here? 127 minus 75, that is 52, that's fine. The next one was also fine. 37 minus 13. Let's use the calculator. Okay, I'm sorry. Yeah, that's fine. 24. 75 minus 37. that is 38. 129 minus 75. 54. 38 minus 24, that's 14. And 54 minus 38, that is 16. Maybe I've written the sequence wrong. Let me just find another sequence from somewhere. That was 215, 52, 127, 256. Okay, so we have 13 here, 37 here, 75, 129. 54 minus 38. That's 16, right? Okay, what if I were to try and change this? I could make this 52 somehow. And if I can do that, then that should become 75 plus 52. And that's 127 then. And then this times 2, 254. Okay, so I've changed the sequence. Let's say it was this. Okay, so I wrote that sequence wrong earlier. So let's say we have a sequence like this. 215, 52, 127, 254. Okay. Let's find the first difference for the sequence. The first differences are these: 13, 37, 75, 127. Then we find the second differences. These are these. And then we find the third difference, which turns out to be constant. It's 14, 14. If you had more terms than this, you would see that the difference will remain constant. Now, what are the values of D1, D2, and D3 in this? D1 is going to be this first value. That's 13 in this case. D2 is going to be the first value here, which is 24 in this case. And D3 is that common difference that we're getting the third time, the third difference, that is 14. Given these values, we can find the nth term of a cubic sequence like this if we ever had to. You, again, as I said, you won't find this in past papers yet, but the syllabus says you should know this. So n minus 1 times n minus 2, d2 over 2. This is what this quadratic formula looked like. We will add to it on the same pattern another term, and that will look like this: n minus 1 into n minus 2 into n minus 3 divided by, instead of 2, we've got 6 here, times d3. So the number in the denominator, this is basically coming from this product, 1 into 2. In this case, that was 2. In the next case, it's 1 into 2 into 3. That is 6. That's why we've got 6 here. But that's the formula that I would just recommend that you remember. In case you have to find a cubic sequence ever, this is how you can do that. Just input the values of D1, D2, and D3 here. Then you have to do some simplification. That will require some effort. But eventually, you'll get the formula in that term. So if it happens to be that you have to use this formula, they will hopefully give you more marks for that as well. Okay, so it will justify the use of the formula. Again, as I said, this is just in case they ask you to find a cubic sequence, you should know this formula as well. All right. Now, this is the second type. This is the third type of sequence that you can have. We've talked about 3 sequences until now. Arithmetic sequence, which is also known as a linear sequence, or a quadratic sequence. This you definitely must know. And then a cubic sequence, which is just something that it's good to know in case they end up testing that, because it's part of the syllabus. Okay. Then what you need to know is some sequences which are going to be square sequences. So basically exponential sequences as a whole. Exponential sequences. Exponential sequences are where the nth term has n in power. Exponential sequences. These are also known as geometric sequences, as you will learn when you go to your A level. You can also call this a geometric sequence. That's another sequence that you need to know of. The most common amongst these are where you have a square sequence or a cube sequence. So for squares, you should remember the perfect squares, right? 1, 4, 9, 16, 25, 36, 49, and so on. What's the nth term of the sequence? It's just n squared, right? So the first term is 1. So if I were to write down the values of n here, you can say n is 1 here, 2 here, 3 here, 4, 5, 6, 7. What if it was n? What would be the term? That will be n squared. So the nth term formula of the sequence is n squared. Okay. Then you can have a cubic sequence. Again, you should remember the cubes. 1 and then 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. 6 cube is 216, and so on. If you have a sequence like this, now when n is 1, the value of the sequence is 1. When n is 2, it's 8, then 3, 4, 5, 6. Whatever it was n, the sequence would be n cube. Okay, so the nth term of the sequence is n cube. Now, this is going to be easy to figure out if it's just like that, right? If they just give you n squared, or if they just give you n cube, then it's easy to figure out. Sometimes they will change it slightly, right? So you remember the squares, you remember the cubes, but sometimes they will not start from 1. Sometimes they'll start from some other number. So they might start the sequence from here. They might start the cubic sequence from here. Okay, what do you do in that case? Let's take an example. Let's say you have a sequence that looks like this. 18, or let's use a simpler example first. Let's say you have 16, 25, 36, 49. You have this sequence. What's the nth term of this sequence? Now, if it started from 1, we could say that is just n squared, right? But in this case, it's not starting from 1. It's starting from 16. How do we think about this now? What we can do is we can write the position of each term. Let's write it down like this. The position of each term. This is the first term. This is the second term. This is the third term. This is the fourth term. And you have the next terms after this. We want to see when it's the nth term, what should we write here? That will be the nth term of this formula, right? Now, to make it easier to understand, you could write another thing here. What is 16? 16 is 4 squared, right? 25 is 5 squared. 36 is 6 squared. 49 is 7 squared. You notice the pattern? What's happening? Whatever is the position of the term, if it's the first term, you have to add 3 to that and then square that, right? So 1 plus 3 and then square that thing. If it's the third term, you have to add 3 to that and then square that. If it's the fourth term, you have to add 3 to that and then square that. If it's the nth term, what should you do? You should add 3 to that and then square that. That will be the nth term formula of the sequence n plus 3 whole squared. That's the nth term of the sequence. Make sense? Let's take another example. Let's say you have something like this. 0, 1, 2. Or let's make it cubic. 0, 1, 8, 27, 64, and so on. Now, do you recognize these numbers? These are cubes, right? This is the sequence. We need to write down the nth term of the sequence, the nth term formula of the sequence. Now, these are all cube numbers, okay? What you do is you write down n here, position of each term. This is the first term, this is the second term, this is the third term, this is the fourth term, fifth term, and so on. How do you describe these terms? These are cubic numbers. So the first number is 0 cube. The second is 1 cube. Then you have 2 cube. Then you have 4 cube. Sorry, 3 cube. Then you have 4 cube. You notice the pattern? If the number here was n, what are we doing for each term? If it's the first number, we are subtracting 1 from that to get 0 and then finding cube of that. For third value, what we're doing is we're subtracting 1 from 3 and then taking cube of that. For the fourth value, we're subtracting 1 and then taking cube of that. Similarly for fifth and so on. So what about the nth value? What we would do would be, we would subtract 1 and then take cube of that. And that will be the nth term of this formula, n minus 1, and nth term of the sequence, n minus 1 whole cube. Okay, that's what you can do here. I hope that makes sense. Let's take another example. Now they could change this another way as well, a slightly different way. Let's say you have a sequence that looks like this now. So in this case, this was the sequence, right? In this case, this was the sequence. Now, similarly, let's say you have another sequence, and that is 3, 6, 11, 18, 27, 38, and so on. Now, what about this sequence? 3, 6, 11, 18, 27, 38. Now, is it a linear sequence? Well, it's not, because the differences are not constant. The differences are 3, 5, 7, and so on. It's not a linear sequence. It is actually a quadratic sequence because the second difference is constant, right? The second difference is 2, 2, 2, 2, and so on. So one idea could be to use that quadratic sequence formula, knowing that the value of D1 is 3, D2 is 2, and the first term is 3. You could use that quadratic sequence formula and that will give you the result. That's one idea. That's one possibility. But mostly, you end up having will that quadratic sequence work here? Okay, I'm sorry. So I made that heading wrong here. So I'm sorry. So this is under the wrong heading. These are not exponential sequences. I wrote that wrong here. That's actually a different type of sequence. Square and cube, these are basically examples of quadratic and cubic. Okay, so squares are basically a specific case of quadratic sequences. Cube is a specific case of cubic sequences. These are not exponential. We'll talk about exponential next. Because we don't have n in the power here. And we have n raised to power something and it's not the power itself. So these are not exponential. That terminology was wrong there. But let's look at the sequence again. Let's look at this again. So this was 3, 5, 7, 9, 11. Then the second differences are 2, 2, 2, 2. One idea could be to use that quadratic sequence formula that we learned earlier. That was a plus n minus 1 times d1 plus n minus 1 times n minus 2 divided by 2 times d2. You could input values in that, find the formula. The other idea could be to use the square sequence. If you're able to recognize that, this is the square sequence, right? It could be done much quicker if you're able to figure out that it's just the square sequence plus something, because when n is 1, what's 1 squared? That's just 1. When n is 2, what is n squared? That is 4. When n is 3, this is going to be 9. When n is 4, this is going to be 16. When n is 5, this would have been 25. When n is 6, this would have been 36. Now, notice what's happening here. These are the square numbers: 1, 4, 9, 16, 25, 36, and so on. These are all square numbers. The sequence that you are given, you are just adding 2 to all of those numbers. 1 plus 2 is 3, 4 plus 6 is 4 plus 2 is 6, 9 plus 2 is 11, 16 plus 2 is 18, and so on. This sequence is n squared. What should be the sequence that's below there? You're just adding 2 to the whole thing. That becomes n squared plus 2. So the nth term formula for this sequence would be n squared plus 2. You can write it down directly if you're able to recognize this. And a lot of times what happens is they will make you do in steps. So they might have a table in which they ask you to fill the table such that the first row contains these numbers, then the second row contains these numbers, and then in the third row, they have another sequence for which you need to write down the nth term. Now, if you're able to recognize the pattern there, it will make things much quicker for you that, okay, all you're doing is you're just adding 2 to each number. So if the previous sequence was n squared, you just have to add 2 to that. Okay, and that makes this much quicker. Rather than having to use this formula for a quadratic sequence, you could do it directly like this. Okay, so sometimes you have to recognize the pattern that is there in the question itself. So when they make you do this, you should be able to recognize from that you're just adding 2 to each number to get the second sequence. If that does not work, if you're not able to figure that out during the exam, then this is the backup that you should know about, and that is this quadratic sequence formula. In that case, you could just use that. Okay, so if you can't figure out the pattern from the question and you know it's a quadratic sequence, then this formula would be the backup that you use. You just input values in this, and you would get the same result from that as well. That would have been n squared plus 2. Okay, so that's what happens when you have a quadratic sequence or a cubic sequence. A lot of times those sequences are just going to be connected to the square sequence or the cube sequence. Okay, all right, now the last one, that's an exponential sequence. An exponential sequence, I wrote a quadratic sequence earlier instead of an exponential sequence. An exponential sequence would be something like this, where you have, for instance, 1, 2, 4, 8, 16, 32, 64, and so on. Now, notice the pattern here. How are you getting the next terms? We're just multiplying by 2 to get the next term, right? So from the first to second term, you're just multiplying by 2. From the second to third term, you're just multiplying by 2. From the third to fourth term, you're just multiplying that by 2. This is basically 2 raised to the power n, where you have n in the power. So when n is 1, 2 raised to the power 1 is, in this case, in fact, it will be 2 raised to the power n minus 1, because it's kind of shifted to the left. When n is 1, you'll get 1 from this. When n is 2, you'll get this. Let me actually make it simpler. For this first example, let's say it's just this. It starts from 2. If it starts from 2, in that case, it would just be 2 raised to the power n. So when n is 1, it's 2. When n is 2, it's 4. When n is 3, it's 8. When n is 4, it's 16, and so on. It's an exponential sequence. This is a sequence where you have n in the power. Okay. Mostly in your syllabus, it's going to be something very straightforward that you'll be able to figure out from the question itself. If you have another one that looks like this, for instance, 3 9, 27, 81. What's this? How are you getting the next terms? You're just multiplying by 3. Okay. This is 3 raised to the power n. Okay. So you're just multiplying that by the same number to get the next term. Now, these sequences were starting from 2 and starting from 3 respectively. That's why we could write down the nth terms directly like this. If it's something more complicated, there's a formula that we have for this, and that looks something like this. Tn equals ar raised to the power n minus 1, the nth term of an exponential sequence. A is still the first term here, and r is the ratio between the terms. So the number that you have to multiply with, that's basically r. That's the ratio between terms. Let me write that in words. Number you have to multiply with to get the next term. You have this formula for for an exponential sequence, which you could use if you wanted to, but mostly you'll be able to do it directly without having to use this formula. You'll do this later in A levels, but for now, it's mostly going to be just as simple as this, or there'll be some other pattern in the question itself that you'll be able to figure out. But just be aware that it is possible sometimes that you have n in the power. In this case, if you had to use the formula for the first sequence, for instance, what would you do? A is the first term. What's the first term here? The first term in this case is 2. Okay. Into r, the ratio, the number that you're multiplying with, that's also 2. Raised to the power n minus 1. Now, 2 raised to the power 1 into 2 raised to the power n minus 1, the powers get added. You have 1 plus n minus 1, and that leaves you with 2 raised to the power n. So the formula works in this case as well. But mostly, since the sequence, if it comes in the exam, it's going to be very straightforward to figure out from the question statement itself. You would not generally need to use this formula. You might see this being used in some resources, but you can do everything without this as well. Okay, I'm just writing it down in case you want to learn, in case you want to memorize this, but you can do everything without this as well. Okay, this is another type of sequence that you will come across where you have n in the power. You will be able to figure it out from the question statement. Now, what we'll do is we'll have a look at some questions now to understand another thing that will sometimes happen, a pattern that you'll have to figure out from the question statement itself. So we'll have a look at a couple of examples quickly in which you will have to look at the pattern and figure out what the nth term is going to be. Let's start from this example. The first 4 terms of a sequence are these: 55, 53, 49, 41. These are the first 4 terms of a sequence. And they've given you the nth term of the sequence themselves. 57 minus 2 raised to the power n, that's the nth term of the sequence. Okay. Now, they say calculate the 5th term. Okay, how can we do that? We have the first term, the second term, the third term, the 4th term. We want the next term after this, right? That's the 5th term. We can use the nth term formula that they've given us. 57 minus 2 raised to the power n, right? If we are looking for the 5th term, we can just put n equal to 5. So it becomes 57 minus 2 raised to the power 5. What would that be? 57 minus 2 raised to the power 5. What's that? 2 raised to the power 4 is 16. 5 is 32. 57 minus 32, and that gives us 25. This should be 25. We write that here. This is 25. Now, this is an exponential function, exponential sequence, right? This is an example of that, how it could be tested. But now in the second part, see, they've given you another sequence, and they're asking you to write down the nth term of the sequence. You see, the emphasis is on write down. That means you should not really have to do much calculation to be able to figure this out. You should be able to write this down directly somehow. Now, how can we do that? Is it a linear sequence? It's not. It's not a linear sequence. This is -1, this is -3, this is -7. The differences are changing. Even the second differences, they are not the same. This is -2, this is -4. The second differences are also not the same. It's not a quadratic sequence. It's not a linear sequence. What sequence is this? Now, when you have something like this, when you can't figure out what sequence the numbers written are following, notice what they have already asked about in the previous parts. They've given you this sequence in the first part. Let me write down those numbers here: 55, 53, 49, and 41. These were the numbers that we were given earlier. The first term was 55, the second term was 53, the third term was 49, the fourth term was 41. Okay. Always write down the term numbers here like this as well, and that will help you understand the pattern that is emerging. The value of n is 1, 2, 3, 4, 5. Okay. Then the first sequence that they've given, that's 57 minus 2 raised to the power n. 57 minus 2 raised to the power n. That's the sequence, and that's the nth term formula for the sequence that they've given. Okay, that's 55, 53, 49, 41. Okay. This is the sequence that they've given us now. 56, 55, 52, and 45. Notice what is happening. When you write these sequences down like this, one on top of the other, so you write one sequence and then write the next values below those numbers, and you have n written like this, you will mostly be able to figure out some kind of pattern from that. You have 1 here, you have 55 here, and this is 56. So 56 is basically 1 plus 55. Okay. 2, 53, 2 plus 53 is 55. 3 and 49, 3 plus 49 is 52. 4 plus 41 is 45. So what they're doing is they're basically just adding the first row and the second row. What does the first row represent? The first row represents n. What does the second row represent? The second row represents 57 minus 2 raised to the power n. What should be this then? It should just be the sum of those two. You can say that's 57 minus 2 raised to the power n plus n. That's the nth term of the sequence. Now, this is not something that you can learn. You can only figure it out from the question itself. As in, it's not something that you can memorize. You have to figure out this pattern from the question itself like this. Okay, so it's very helpful a lot of times that you write down the sequences like this. You write one sequence, and below that you write the other sequence, and then on top you have n written, and that will help you understand what pattern is being followed in that particular sequence. Let's take another example. Let's say we've got something like this. The sequence of positive integers is arranged in the pattern below: 1, 4, 7, 10, root 2, 5, 8, 11, 3, 6, 9, 12, and so on. First of all, they're saying complete row n. So basically, the nth term formulas for these sequences, you have to write them down. Now, what type of sequences are these? These are both linear sequences, 1, 4, 7, 10, right? The differences are all threes. It's a linear sequence. We can write down the nth term using our nth term formula for this: a plus n minus 1 times d. What's the first term? It's 1. Difference 4 minus 1, that's 3. Simplify this: 1 plus 3n minus 3, that is 3n minus 2. This would be 3n minus 2. Okay. What about this? You can do it using that nth term formula as well: a plus n minus 1 times d. You can say that is 3 plus n minus 1 times the difference, which is 3. 3 plus 3n minus 3, and that gives you 3n. This is 3n. Now notice it's just 1 mark. Isn't that a lot of working for 1 mark that you're finding the nth term using this formula, then this formula, and the total mark is just 1, right? That's very little. That's just 1 mark for quite some working. Could we do it quicker than that? Could we do it quicker than that by looking at some pattern in the sequences that we're given? You've got 1, 2, 3 in the first row. In the second row, 4, 5, 6, 7, 8, 9, 10, 11, 12. The number on the left side is 1 less than the number in the middle. The number on the right side is 1 greater than the number in the middle. That's the pattern that's being followed here. The number on the left is 1 smaller. The number on the right is 1 bigger. So if we know the nth term of the middle sequence, 3n minus 1, what is going to be the number on the left side? 1 less than that, 3n minus 1 minus 1. What should that be? That should be 3n minus 2. We could just write that directly like this. What about the one on the right side? This should be 1 bigger than the number in the middle. 3n minus 1 plus 1. That is 3n. That is why it's just 1 mark, because you have to look at the pattern below. And that makes things much quicker. Okay, if you just had this sequence given in isolation, then you could use that linear sequence formula. But in this case, it's much quicker to just use this pattern to figure out what the nth term would be. All right, now the table shows some results obtained from this pattern. 1, 2, 3, 4, 5, and up to n. Okay, square of the middle number in the row. Square of the middle number in the row. All right, so 2 squared is 4. 5 squared is 25. 8 squared is 64. Now, what about the next one? The next one is going to be 11 squared. 11 squared, what's that? That's 121. Okay. This should be 121. Then, what about this? Product of the first and the last number in the row. Okay. 1 times 3, that's 3. 4 times 6, that's 24. 7 times 9 is 63. 10 times 12, what should that be? That should be 120. Okay, so we completed this column for number 4. That's the part B1. All right. Now they're saying, find an expression in terms of n for y. Find an expression for y. Okay. In terms of n, so we want the nth term formula for y. How can you figure that out? Let's look at any pattern that might be emerging from this. This was 4, this is 3. This was 25, this is 24, 64, 63, 121, 120. The numbers below are just 1 less than the numbers above. If we can somehow figure out the pattern for the middle row, so for x basically, if we can figure out the pattern for x, can we just figure out the pattern for y as well then? It'll just be 1 less than that, right? What's x? When this number is 1, this is 4. So it's the square of the middle number, right? So in fact, you can just use that directly. The middle number is 3n minus 1, right? You have this here, 3n minus 1. So this should be 3n minus 1. And then you could say this is just 3n minus 2, because it's 1 less than that. 3n minus 2. Okay. Another way to think about this could be using what they have described here, product of the first and the last number in the row. Another idea could be that you multiplied these two. First number, 3n minus 2, and the last number, that's 3n. And that will give you 9n squared minus, 3n minus 2 whole squared I missed the square there. This should have been 9n squared minus 6n. Okay, I'm sorry. I missed the square there. That was 3n minus 1 whole squared. And then this number below should have been 3n minus 1 whole squared minus 1. Okay, so this becomes 3n minus 1 whole squared minus 1. That's one way to do this. Another idea could be using these nth terms that they've given us, 3n minus 2 times 3n. That would have given us something similar as well. 3n into 3n, that is 9n squared minus 6n. That's equivalent to this. You can verify this as well, because this is 3n minus 1 whole squared, which becomes 9n squared when you expand it. 9n squared minus 2 times 3n, which is 6n plus 1 minus 1. And that simplifies to 9n squared minus 6n as well. And that's what we got here as well. So you could do it both ways. You would either just multiply these two numbers, 3n minus 2 and 3n, and get this. Or you could use the pattern. In the table, where the last row is just one less than the row above, right? And the row above is 3n minus 1 whole squared. You just subtract 1 from that, and you get this result. Okay. And the last part they're saying, show that x minus y is always equal to 1. Now, you can use any one of these two forms that you've written. You could use this one or this expanded form. Both are acceptable. Find the difference x minus y. Okay, what's x? X is 3n minus 1 whole squared. 3n minus 1 whole squared minus y, which is 3n minus 1 whole squared minus 1. Let's simplify this. This gives us 3n minus 1 whole squared minus 3n minus 1 whole squared plus 1. These two get cancelled. No matter what the value of n is, we would end up getting 1 from that. So x minus 5 is always equal to 1 for this reason. Okay. I hope that makes sense. What I've done is I have added a few more questions in this OneNote. I would recommend that you attempt these questions in addition to others from the worksheet that I upload tonight. And then if you have any problems in them, we will discuss them tomorrow. So tomorrow we have to do two things. One, there was one thing that we were left with in sets, and that was some questions where we had some scenarios given, where we could have some scenarios. Let me show you a question like that. For instance, yeah, so I don't have them right now. But tomorrow we'll do questions where they give you some word problems on sets. That's one thing that we want to do tomorrow. And the second, we want to do practice questions on sequences. We're not going to do something new tomorrow. Just practice. We'll just practice sequences and sets. Okay, that's for tomorrow. For now, that's it. I'll see you again in the next class. But make sure to attempt questions from the worksheet, from the previous worksheets as well. If you have any questions, we could discuss all of them tomorrow too. Tomorrow is just going to be a practice session. So until now, if you have any problems from any of the worksheets, please make a list of them so that in the next class, we could discuss them. All right, that's it for today then. I'll see you again in the next one. That's tomorrow, which is going to be a practice class. But it's important for that you let me know what problems you're having. For that, you should have practiced before. I'll be uploading this worksheet today as well. It's in the OneNote notebook as well. The questions that I've posted here, that I've added to the notebook, there are some of the more complicated ones. I would recommend that you attempt these first, and then more from the worksheets that I upload. And let me know if there are any problems. Okay, I'll see you again tomorrow. I love this.